In this lecture, we will be working with Lambda expressions, which are Python's syntax for creating anonymous functions. We can refer to the latter as Lambda functions as well. So, in what situations can we use such functions to our advantage? Well, sometimes you may need to involve a simple functionality in larger Python programs or expressions. In other words, there are cases in which you will prefer not to define a whole new function. You know what I'm talking about. Having to think of a name using the def keyword and indentation, and so on. This is too big of a hassle if you are certain you won't need to refer to that function beyond a certain program. What you can do instead is use a short and elegant syntax to create a function that will allow you to focus on the function itself, rather than think about its name or place in your work. That's where you can opt for using anonymous functions. This probably sounds like an odd concept, but don't worry. It will quickly become crystal clear. We will begin with the approach you are already familiar with, creating and naming a function. So let's write a function called raised to the power of 2. Its name clearly indicates what value will be returned. If we execute the function with an argument of 3, for instance, we'll logically obtain 9. All right, what we'll do next is create a Lambda expression that will execute the same calculation. The syntax we need here is the Lambda keyword, parameter, colon, and an expression involving the same parameter. This means we need to write Lambda x colon x double star 2. However, if you execute the cell now, you will only see a message indicating that we're having a Lambda function. Therefore, what we can do is assign a Lambda function to a variable called raised to the power of 2 lambda. Then, as we execute raised to the power of 2 lambda with an argument of 3 specified in parentheses, we obtain the value of 9 once again. It is very important to note that the above statement was somehow contrary to the best feature of Lambda functions, because assigning an anonymous function to a variable practically gives it a name. However, this trick worked great at the minute since it helped us explore the syntax of Lambda expressions and displayed the outcome of a Lambda function for us. Moreover, it exemplified the fact that a Lambda function is completely equivalent to an ordinary function. Okay, now let's see what we can do to apply a Lambda function without using this trick. Imagine that we want to write a Lambda function that delivers as an output the value of the provided argument divided by 2. To achieve this, we will need to write Lambda x colon x divided by 2. This time, though, I will place the Lambda function in parentheses. Then, if I assign, say, 11 as the argument of lambda in another pair of parentheses, I can expect to obtain 5.5. Is this correct? Yes, it is. Great. Therefore, instead of defining a whole new function that I'll only use once, I have parameterized the division by 2 and passed an argument of 11. As a matter of fact, this characteristic is extremely handy when your Lambda expressions are much more complex. For instance, if you need the following mathematical expression to be executed by a certain program you've written, running a line of code as this one can be the perfect choice. Nice! Another feature of the Lambda functions is that they can have multiple parameters. To create a relevant example, we will work on the same structure. Assume that we want our output to be the sum of 2 provided arguments, so we can write lambda x, comma, y, colon, and then write our expression, which is x plus y. To visualize the output of this function, we will store it in a variable called sum underscore xy. If we execute sum xy with arguments of 2 and 3, we will obtain 5. Okay, here comes the most interesting part. Y does not necessarily have to be a value. It can also be a function of x. Say that we are interested in obtaining the sum of x and the output of the function y with an argument of x. In that case, in terms of code, we only need to add x in parentheses right after the letter y in our expression. Execute the cell to confirm the change. Good. So, what is the correct way to insert arguments for this function to successfully produce an output? For the sake of exercise, let's execute this function with arguments of 2 and 3. As you probably expected, we obtained an error message because the second argument, which is just an integer, cannot correspond to a function, which is what y is in our Lambda expression. Then you may consider running this function with a single argument, which will substitute x in our expression and be used in the calculation of y, thus hopefully leading to a numeric output. Let's try that. Sum x, y with an argument of 2 leads to another error message though. It says that we are missing the second argument in our expression. Therefore, we will get an error message whether we provide 2 numeric values or just 1. How come? Well, the deal here is that x can be a numeric value, but y has to be a function, since we set it to be a function in our expression earlier, right? That's why instead of providing another integer like 3 here, we need to provide a function. Thus, this expression becomes a great example of how instead of defining a separate function with a name, we can use another lambda function that will take the value of the first argument, which is x, and apply it in a calculation to return a certain output. This can be any sort of calculation. For instance, x times 5. If we execute the cell now, we will finally obtain a value, the value of 12. Great! The last line of code contains the most realistic example of how a lambda function can be used in larger expressions. Hence, please focus on that code cell as we're summarizing the features of anonymous functions in Python. Lambda functions can have one or many parameters, but can contain a single expression only. Lambda functions allow you to write just one line of code to include a simple functionality in a more complex expression. Unlike regular functions, lambda functions can only be applied to the larger expression they have been written in. They cannot be referenced elsewhere in your work. Please don't skip the exercises attached to this lecture, as solidifying your understanding of anonymous functions is very important for your work as a Python programmer. You will surely encounter lambda expressions often, so you need to be prepared and not stumble while reading other people's code. I hope you enjoyed watching this video. Catch you later!